Class. This is secondary 3, woohoo! And we are on the very last lesson that you're going to have to hear all year long, which is really awesome. 10.3, area of triangles. Okay, so where you're looking at in your notes, your 10.3, you're going to see this area of triangles and a diagram of a triangle, and it's triangle ABC. Now, triangle, whoa, what happened there? Triangle ABC is unnecessarily a right triangle. And H is just the height, and you notice it's dashed in there. So what we're dealing with here are triangles that we don't know, or we're not sure that they are right triangles, and we don't have the height. So in the beginning, what we actually had was the triangle ABC, and that's it. All right, and it's not a right triangle, so we're not sure exactly if we have all the parts that we need to find an area, because the formula for the area of a triangle is 1/2 base times height. That's your area of a triangle. I should probably put area of a triangle there. 1/2 base times height. Now, to do that, we have to know this base here, and we've penciled in the height there. That's height from there to there, and we've penciled that in, meaning we don't really know what the height is. So if we don't know the height, then what can we do? Well, fortunately, we can use trigonometry. All right, we know that sine of angle C, which is right here, this angle we're dealing with, angle C, okay? The sine of C is opposite over hypotenuse. So opposite over hypotenuse for angle C of this smaller triangle is H over A. Okay, opposite over hypotenuse. Now, if sine C is H over A, then H is equal to, if I want to solve for H, I'm just going to write this out here. We have sine C equals H over A. If we wanted to solve for A, what we do is we times by A if we solve for H. I don't know what I said, but I meant solving for H. So if we times both sides by A, we get H, because the A's divide out, is equal to this. So H is equal to A times the sine of C. Now H is height, remember, of the triangle. So if our height is A sine C, then all of a sudden we have a way to come up with C. We have to use our sine function, but that's all right. The sine function will work just as well. And remember, this is the angle C, so sine function, as long as we have that angle, can help us when we're finding an area of a triangle. So for a non-90 degree angle triangle, all right, or one where you don't have the height, then we have trig to help us with our actual area of a triangle, and we're going to use this formula, area equals 1/2 base, and then we're going to replace height with A sine C. A sine C. And that C is a big C, it's an angle C. All right, so that is going to be our area for a triangle. And it's not too bad. It's useful. We can use it. However, we do need to know some angles, and we therefore don't have to actually have height anymore. Notice height is invisible. It's no longer in that triangle, which is so sweet. Okay, so I'm going to move my face out of the way. I always just leave it there so that you guys know it's me teaching, and you don't have to be afraid there's just some voice out there. All right, example 1. Find the area of the triangle to the nearest tenth. All right, now notice in these triangles you have kind of a wrapper, sort of. In order to do these problems, you need this setup in order to come up with the area. You need a wrapper. You need a side, angle, side. All right, just so you know, because those are where your A, B's, and C's come from. All right, and then your area is going to be 1/2, and then that B and A, because this is angle C, so this is side C. Just letting you know that's side C, because remember, it's across from angle C. Remember, little c is across from angle C. So it doesn't necessarily matter which side is A and which side is B. You know the other two sides are A and B of the triangle. So you're going to do 1/2 times the two sides of the triangle, which wrap the angle C. So 15 times 12 times 1/2, right? And then we do sine of 110, which I didn't do a very good job of leaving myself room. Let me erase all this. So you know that's C. Put it right up there. So you know that's C, and in the formula, 1/2 B times A times the sine of C means 1/2 times each of the two sides that you do have. In this case, they're 15 and 12, and then times sine of the angle between them, 110. All right, so let me plug this in my calculator. Again, remember to make sure you're in degrees, and it's going to be 0.5, I just use 0.5 in my calculator, times 15 times 12, and then I just plug in sine of 110. And part of me thinks that you should probably want to see how I put that in the calculator, just because it is useful to be able to see it. I don't know, maybe not, but I would think that you would want to see how I put that in the calculator, just as a little helpful thing here, 500 things here. Okay, so 0.5 is there times 15 times 12 times the sine of 110. All right, and then you hit enter, and that means the area of the triangle is 84.57. And I think it's to the nearest tenth, so 84.6. All right, so my pen back. 84.6. And it's centimeters. So make sure you put the units in there. Oh, squared, because it's area. Ooh, made that go away. So 84.6 squared centimeters, because we're dealing with area. Okay? All right, so here we have a side and an angle and a side, which is the correct setup for this, using this formula for the area of the triangle. So again, we're going to do 1/2 times the sides that wrap it, 23.5 times 24. And again, it doesn't matter which one you do first, which one you do second. You just know that you have to have the two sides, and it's multiplication, and multiplication does not respect order. As long as you're multiplying everything together, it doesn't matter what order you have it in, times the sine of the angle between them, 25 degrees. All right, so in the calculator, I'm actually just going to go up and extract it and plug whatever in. 23.5 times 24 times the sine of 25. So check it out here. As you can see, 1/2, 23.5. So 0.5, 23.5, 24 times the sine of 25. All in there like that. 119.2. Looks like 119.2 inches squared inches. Okay. All right, and then the next one, we have these two sides. Now those two sides don't have it has an angle between them, but we don't have the actual measure of that angle, but we have a way or a means to find it. It's going to be 180 minus 24 plus 31 in parentheses, because if we add those together, 24 plus 31, what is that, 55? And 180 minus 55 is 125 degrees. So this angle can be found, and that's the angle we must have. We must have the angle between the two sides that we know. So it's going to be 1/2 times 17 times 14 times the sine of 125 degrees is how we would set that one up. Now, sometimes I just like to take 1/2 of 14, 17 times 7 times sine of 125, and just kind of do that so I don't have to plug as much into the calculator. And that's fine if you want to do that. If not, if you don't trust yourself to factor things out, just put it in as you see it using 0.5 for 1/2, and that's 97.5, and this is square meters. Okay, so that's your area of the triangle using trig. And just so you know, that's again when you don't have the base or the height. You do have the base, you don't have the height. Okay. If you don't have the height of the triangle, then you can use trig to get your area without it. Now, sometimes you might have to use the law of sines or the law of cosines, which is unfortunate because they're a little more complicated than that last formula, as we know, because we have been working on that, and that's fine. Let's just note that it's fine. We'll just use it. We have a couple of examples here. When we use the law of sines or cosines is when we don't have the correct order. We don't have that wrapper side angle side. All right. We don't have the side angle side. So this is missing. So when that's the case, then we're going to have to use the law of sines or the law of cosines. All right. And what we do is we use the law of sines or the law of cosines in order to get that side. And then after we get the side, then we apply the formula that we use to find the area of the triangle. So in this case, I either need this side, because I just need either of the two sides, that one or that one. Okay. Now, if it's me, I would probably figure out real quick the other angle so that I could just be assured that I can use law of sines, because as we know, law of sines is a little easier than law of cosines. So if we take 180 and we subtract 28 plus 114, 180 minus 28 plus 114, in parentheses, make sure you put that sum, get that sum and subtract it, then I get 38-degree angle. All right, now if that's 38, then I can use this angle and let me write this. I can use this angle on this side and the law of sines, which is awesome. That's what I want to use. So I can do sine 38 over 20 is equal to, which one do you want to use? It doesn't really matter. Let's figure out this one, that side. Okay, and then we'll use the law of sines area formula to come up with that angle 28, right? That will be nice. That's what we'll do. All right, trying to put my face back up here. No, not that I'm sure you want to see it, but it's helpful to have a teacher there. So sine 38 over 20 is equal to sine 114, and across from that is our x that we're looking for. So cross multiply selves. X times the sine of 38 degrees is equal to 20 times the sine of 114 degrees. And then x then is equal to 20 sine 114 divided by sine 38. Okay, so plug that in the calculator. Use your N over D button if you have it, which would be nice. Make sure you get the right answer here in the end. It's much easier when it comes up with a division on its own using PEMDAS. So that's approximately 29.7. All right, so right here is 29.7. Now, in my calculator, I have that. I'm going to just use it, and I'll show you how in a second. But that's our step one. We found the side that has the wrapper, so we have our wrapper. And we like wrappers, right? Wrappers are cool. We have side angle side. So we're going to set up our 1/2 times 20 times 29.7 times the sine of that angle between them, 28 degrees. So this becomes our wrapper that we have side angle side for to calculate the area of that triangle. All right, now I like to just do that and write in 10 times 29.7 times the sine of 28, and we'll plug that in the calculator. I'm going to actually put this in the calculator up so you can see it. So I'm going to put in 10 times, and remember how we extract, we highlight and hit enter, and that just puts it in, and it puts in all of it that at least we have. We know that's an irrational number and it never ends as a decimal, but it extracts as much as possible to get as close to an answer of the true area as we can. And then sine 28. All right, just plug that right in the calculator. 139.3. 139.3. Okay. So 139.3, and that is an area in inches squared. Area of the triangle. All right, not too bad. Oh wait, I need to see what my time is. That's important. Oh dang, I've gone over. All right, let me stop this one and we'll do the next one on the next slide or the next video part 2.